And I'm back. Anyways, I'm not redoing this. There's nothing really unique about it. I just realized when I was looking at it that I made a mistake the first time I did it, and I had to go back and fix it. So you guys would have the right answer on your key. Find the domain of the root. Here's the original question. Find the domain of the root of 6x minus 150. And here's a similar question. Find the domain of the fourth root of 3x minus 10. When you talk about all even roots, so you have maybe the square root, the fourth root, or the sixth root, whatever. The fourth root of something, anything, its domain must be that a is greater than or equal to 0. Or if the radical is in the denominator, the domain is now that a is greater than 0. So you just have to remember those little rules about it. We talked about that in class. The 0 is from the smallest thing you can take the square root of. If the radical is in the denominator, you can't be 0. So that's why we dropped equality. But this one's straight up in the numerator. So 3x minus 210 must be greater than or equal to 0. 3x is greater than or equal to 210, and x is greater than or equal to 70. Not a hard problem. 11, long division. So long division is something you guys will struggle with. When I do this one, I'm actually going to check my work and see if I got it right, and I'm going to show you how to check your work to see if you got it right. Hopefully you can take that little skill and apply it in other ways. All right. It's actually pretty easy to check your work. You can use either storage feature or something I like even better, graphical equivalency. I actually like graphical equivalency over the storage feature. So to turn an x squared into a 4x cubed, I multiply by 4x, and then I invoke the distributive property. 4x squared minus 4x. You guys didn't do all that well with the whole changing of signs things that I was trying to teach, but do remember you subtract this line. That should be a 3. And the 4x is in the wrong spot. I'm having a Monday. Too bad it's Wednesday. But I'd have a 4x cubed minus 4x cubed with nothing. This piece has to be carried down, minus 2x squared. And a negative 2 minus a negative 4 is plus 2x. Easy enough. Now what am I going to multiply by? I need to turn this x squared into a negative 2x squared, so I multiply by a negative 2. That'll give me negative 2x squared, and then plus 2. So I'm going to bring this negative 1 down because I need it. I'm going to wrap before I subtract. I'm going to bring down the 2x, and negative 1 minus 2 is negative 3. So what I end up with, the quotient is 4x minus 2, plus the remainder, 2x minus 3 over x squared minus 1. Now look at this 4x piece. That comes from doing what I like to call near math. 4x cubed over x squared is 4x. That's some near math. And that will usually eliminate at least one choice. If things are multiple choice, there's always something out there that is going to eliminate choices, which is huge. I wish more kids understood how to take tests. You can give me a test on Japanese. I'd probably still pass it. I don't know Japanese. But I'm a very good test taker because I look for little details like that. But anyways, let's see if I'm right. All right. So here's a pretty good skill. Going to y equals, and it's something, and it's not hard to do. Math, numerator over denominator, 4x cubed. What I'm doing is I'm typing in the original function. Whoops, pressed that enter key too soon. If you don't have a calculator, our librarian is back now. She can check you one out until ACT. You have to give it back for a week or so, and then you can check it back out again. And I'm just going to look at the graph, zoom 6. I want to see what the graph looks like. These are rational functions. The graphs are usually just ugly. There it is in blue. My answer was 4x minus 2 plus math, numerator over denominator, 2x minus 3 over x to the second minus 1. And I'm just going to hit graph again. If these are the same, the graphs will have complete overlap. and they are the same, so I know my answer is correct. That, boys and girls, is how you check your work, or on a standardized test, how you do no work. All right. Number 12, find the inverse of a function. There's 3 steps in writing an inverse. Step 1 is to swap x and y. Step 2 is to resolve for y. And step 3 is to replace y with something that is read the inverse of f of x. Oh, nice to know there's no viruses. So here's your similar question. We're going to follow the first rule. We swap x and y. Why is this here, by the way? That has to deal with the fact that the function is not valid unless this is here. So if x was less than negative 3/2, this would return an imaginary number. That's why that's there. That's the only reason it's there. Because the inverse is not going to be, I have a problem with things less than or equal to negative 3/2, because it's going to be a square. Anyway, it's time to resolve. Step 2. Okay, so let me write down what I did. I swapped x and y. Step 2 is to square both sides, because I want to counteract that square root. So if I square the right-hand side, I get the contents inside, because a square cancels out a square root. And now I'm just going to solve for y. That's going to take more than one step. I'm going to add 3. And I'm going to divide by negative 2. There's my inverse, okay? You might see this written differently. You might see negative x squared over 2 minus 3/2, but they are the inverses, okay? Anyways, now at step 3, replace y with the inverse of f of x. So instead of having y equals, I just have the inverse of f of x. Because if you just say y equals, nobody knows it's an inverse. Nobody knows. 13, find the inverse of this function. Something that wasn't on the original twin that I gave you was this little disclaimer here. You can only find the inverse of this function if x is greater than or equal to 4. So I can show you on Desmos why that's true. Desmos is something you guys might get more experience with next year. It's actually going to be an integral part of the class next year. At least ideally in a perfect world it will be. A lot of things you can teach in Desmos. It's really, really cool to use. Alright, so I've done lost my place here, but that's what I need. That was 3 times x minus 4 squared plus 2. Oh, sorry, I'm doing the wrong function here. The similar question was negative 2 times x plus 2 squared minus 4. Now, I hadn't taught you this yet, but by the time you take the test, you will know this. This is not one-to-one because it fails the horizontal line test. So the reason we have that disclaimer there off to the side, x is greater than or equal to 2. It's been a while since I've used Desmos. I think I have to use that. Maybe I do parentheses. X, need my keypad, greater than or equal to 2. Oh, that's not it. Forgot how you set domain in Desmos. Try curly braces. X greater than or equal to 2. Close curly braces. Well, that's not it. That's also not it. Well, I got something to look up because apparently I've forgotten it. There's a way to have Desmos do domain. I wonder if it legit uses set builder. Probably just wasting your time. Sorry, 2 to infinity. Well, I gotta look that up. Anyways, the reason we have that domain restriction there is because that would throw away the left-hand side of the graph. I'm going to waste a little bit of your time here because I forgot something. Alright, so I want domain and Desmos. It's curly braces. So I wonder why it's complaining. It's curly braces. That's what I was trying to use. Curly braces. X is greater than 2. Maybe I don't need the space. That's crazy. Well, okay, I'll just have to play with this later. I'm wasting your time, and I'm sorry about that. That had nothing to do with what you're concerned with, right? So, anyways, follow your 3 steps listed on number 12. This is going to become x. This is going to become a y. And then we're going to resolve. So we're going to add 4, x plus 4. All right. You can either divide by -2 now, or you can do it later. It doesn't really matter where you do it. It really doesn't. Actually, you should do this right now. I'm thinking about counteracting a square root. So we're going to divide both sides by -2. That's going to free up y plus 2 all squared. And now we're going to counteract squaring by square rooting. Looks a little funky. Once we do that, and I'm going to go off the side, and I'm going to leave this alone, and then I'm going to clean it up later, because I'm really happy if you can get here, because a lot of kids can't. But I'm going to clean this up in just a minute. I have the root of x plus 4 over a -2 is y plus 2. We don't include plus or minus with inverses. We don't. It's always positive with inverses. That's kind of a little bit deal. When you're dealing with inverses, it's always the positive root. I'll write that down over here. When dealing with inverses, it's always the positive square root. All right. So I'm going to subtract 2 now. So y is -2 plus the root of x plus 4 over a -2. You can make that root taller. Then I'll do that replacement. Now, as a math teacher, I actually don't like that final answer. So let me show you what it should be in a perfect world for all of you who are, STEM oriented and going to go become an engineer. You would not like this answer either if you've taken as much math as I have in life. What you would really like to see here would be where you move the negative to the numerator and you clean up the 2 that's in the denominator. So you multiply by √2 over √2. Little things like that will make or break a calc kid. And that 4 should be -2, sorry. Messed up my step there. If you multiply both terms by √2, the 2 goes in inside. And the last thing that you would see, if you take a multiple choice pre-calc or calc test, this is how we write the answers. You see -2, x plus 4, all over 2. Like I said, in Algebra 1, I'm pretty happy right there. But if your job is to require that you move into pre-calc and calc, then that's where you've got to get to. But right now you're in algebra 2, right? You're just hoping to get your 50 or 60. So here's my similar question for 14. The length is, oh, actually I am out of time. Never mind. That's all I got for today. Maybe during lunch break. Who needs to eat anyways?